we're going to use a new method of polynomial multiplication to handle cases where you're doing a lot of foiling if you do it the old-fashioned way. For instance, if you do a plus b and you cube it, you could do some work and find this as your answer. And the work is going to get more and more intense the bigger that exponent is, right? As that's 4 or 5 or 6, it gets crazy. But there's a quick way called Pascal's triangle, and that's going to help us through this. And the first thing I want you to understand is how to construct Pascal's triangle, which is just a pattern. And once you see the pattern, it's very easy. Take a look at these rows so far, the 0th row, the 1st row, the 2nd row, and so on. These are just generated by adding two neighboring numbers and putting the result below them. So if I add 1 and 3, I get 4. And I could fill in that row like this. 1, the edges are always 1. But it would be 1, 4, 6, 4, 1. That would be my 4th row. And that's going to help me figure out a plus b to the 4th power. Okay, and I'll get to that in a moment. The next row after that, if you're interested, would be 1, 5, 10, 10, 5, 1. See if you can pause the video, do the last row, the 7th row. It's going to be 1, 6, 15, 20, 15, 6, adding is hard, and 1. Okay, so this is how you construct the triangle, and now let's talk about why or how this thing actually tells us what the binomial expansion is for one of these polynomials. So take a look at a plus b squared. I could say this is 1a squared plus 2a to the 1, b to the 1, plus 1b squared, right? Well, let me circle these in green. See those coefficients there, 1, 2, 1? That's these guys right here, 1, 2, 1. And likewise, if we go to the next one, I could call this 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. And those are these coefficients right here. So you see that pattern happening, and these are called binomial coefficients. Those are the numbers in the table, in the pyramid. And what I also want to point out is two other patterns, and that's going to help us with the rest of the way. So take a look at the a variables. Okay, I'm just talking about a right now. If you look at a, you see it goes 3, 2, 1, and I could say this is a to the 0th power right there, if I just look at the exponents. And now let's look at b. Okay, if we look at b, this is b to the 0, b to the 1, b to the 2, and b to the 3. So those exponents follow their own pattern. They simply start at the highest number and go down for a, or they start at the lowest number 0 and go up for b. And now we can reconstruct a plus b to any power if we just know the appropriate row in the triangle. So what I want to do as an example here is show you an easier method for dealing with things like this. Okay, we're going to do this one right here. Notice that it's not just something like a plus b. It's complicated. So I'm making this table, and we're going to work through this. And first of all, let's start with the binomial coefficients. Notice that's 4 right there. Well, what are the coefficients of the 4th row? Take a look at this guy. It's going to be 1, 4, 6, 4, 1. So I'm going to put those into my table. 1, 4, 6, 4, 1. And now what I'm going to do is I'm going to fill in exponents for the a variable. Okay, so let's do this in, I'll keep it the same color as before. Let's do this in green. So this is going to be 4x to the 4, 4x to the 3, 4x to the 2, 4x to the 1, and 4x to the 0. Okay, well 4 to the 4th I don't have off the top of my head. What is that? 256, great. That's 256 x to the 4th. 4 cubed, that's not so bad, but it's still kind of big. Let's see, what is that? That's 64. 64 x cubed. And then 4 squared, I know that. That's just 16. 4 to the 1 power is 4. And 4 to the 0th power, 4x to the 0th power is 1. So you see, all I'm doing here is I'm taking what was in place of a, right? These things aren't exactly a, they're 4x. And I'm taking a to that power, or 4x to that power. Let's do the same idea with b. But in this case, b is going to be -3. So I want to start off, remember these exponents start low with b. It's going to start at 0, then go to 1, 2, 3, and 4. So we start at -3 to the 0 power, that's just 1. Negative 3 to the 1 is negative 3. Negative 3 squared is 9. Negative 3 cubed is negative 27. And negative 3 to the 4th power is 81. Now, here's the value of the table. All we have to do at this point is simply multiply everything going straight down. Okay, so we're going to find the product. Well, if I start in the left column, this is not so bad because it's just a bunch of ones and then one giant number, 256. So this is going to be 256 x to the 4th. And now things start getting a little bigger. You definitely should be ready to use a calculator in this one because I have to do 4 times 64 times negative 3. So that's going to be negative 768 x cubed. And this next one, this is going to be 6 times 16 times 9. So that's 864 x squared. The 4th term is going to be 4 times 4 times negative 27. Okay, now the numbers are coming back down again. So it's going to be negative 432x. And this last one's easy. I don't need a calculator for that. That's just 1 times 1 times 81. Okay? The expansion's just about done. Here's the answer. I'm going to say 4x minus 3 to the 4th power equals, and now I add up all my terms. 256 x to the 4th minus 768 x cubed plus 864 x squared minus 432x plus 81. Now, if you want to do this the long way and double check everything I just did, feel free. That's just foiling, right? If you want, you can do, first, outer, inner, last all day long, and let me know if you get the right answer. You should, but it's essentially this, where you multiply every single thing by every single thing, and you combine all your like terms and add them all up. But I think Pascal's triangle is a much better way to do it, much quicker when those exponents get big. And what's nice about this table method is it helps you organize everything so you don't lose track of the big numbers.